Welcome to section 7.4 of Honors Algebra 2 curriculum. It is called Extending Trigonometry. So we are going to expand on what we know about special right triangles and SOHCAHTOA to help us further along our journey in math. So here we go. A little review, and I can see some of this didn't print out very well. I'll make sure you understand what it's saying. It is asking, what is the sign of the coordinates of some point? So x comma y, any point, wherever it is on this coordinate graph, what would the signs of x and y be depending on what quadrant it is? So a little review, some things that you've maybe forgotten is what quadrants of a certain graph are. So up here in the upper right is quadrant 1. Up here is quadrant 2. Lower left is quadrant 3 and lower right is quadrant 4. I really don't know why Roman numerals are used to represent the quadrants. It's just how I've always seen it. If anyone knows why, tell me. I really have no idea. Okay? And then so what we're going to look at is if we have a point x comma y, and it is in quadrant 1, what will the signs be for the x value and the y value? Well, from the origin, to get to quadrant 1, you'd go to the right and up. So you'd have a positive x value and a positive y value. For quadrant 2, from the origin, any point will be to the left and up. So to go to the left would make the x value negative, and to go up, the y value would be positive. For quadrant 3, to go to the left and down, they're both going to be negative. And quadrant 4, to the right and down, the x value will be positive, the y value will be negative. That's going to be important to know to help things go a little bit faster with some of our problems today. A few other things to think about, just some foreshadowing for the future, nothing super needy right now, but to start getting used to the idea that the x value of your coordinate has to do with the cosine of different angles. So when you see the x value, you start thinking cosine, and the y value has to do with the sine of angles. And you'll remember that cosine is defined as adjacent over hypotenuse, and sine is defined as opposite over adjacent. These are all some things that will help us moving forward. Another thing I want to point out is to have us think about this coordinate graph almost as like a spinner. Like if you ever played board games as a kid where there would be like a little arrow pointing and you would spin it to see where it lands. One thing to think about, we're going to use that idea a lot, is that thinking of this almost as a circle, that you could go around quadrants 1, 2, 3, and 4 in a circle, and starting out here with the spinner going from the origin out to the right, you haven't spun it yet, it's at 0 degrees. Let's say you spin it and the spinner goes exactly a quarter away around and lands here, it would have traveled 90 degrees. And then let's say the spinner goes 90 more degrees. Now it's pointing straight to the left. It's gone 180 degrees. If we go 90 degrees more and the spinner spins, it's going straight down. 180 plus 90 is 270. And then if the spinner finishes the circle and gets back to where it started at 0 degrees, it's actually traveled 360 degrees. So that's something you're going to want to start getting used to, the idea of like our coordinate plane having a spinner coming from the origin and things traveling this counterclockwise direction around the circle. And it could travel in a clockwise direction too. I'll talk about that. So this would be a good diagram to have in your notes. If you need more time, pause the video to draw a little more. All right, this next piece has some important vocabulary. Please write down in your notes, angles of rotation. It's going to go back to this spinner idea. An angle of rotation is drawn with an initial side and a terminal side. So the initial side is where your spinner starts. And something for you to get used to is the spinner is always going to start on the positive x-axis. So we've got the initial side on that positive x-axis. It starts at the origin, goes out to the right. okay? And then the terminal side is the other side of the angle, the other ray of the angle where it ends. So if you look at this picture on the left, it's like the spinner. We've got, you got a spinner, it's pointing out along that positive x-axis, and then it turns, it rotates, and it ends here. That's considered the terminal side where it ends. So the terminal side is usually somewhere not on the positive x-axis, but I suppose that's not always the case. So this one, we had a positive rotation because it started at that positive x-axis and went up, working counterclockwise. You could also have a negative rotation where your initial side is on that positive x-axis and it rotates down. So you look, the direction of this rotation is going down. So that's why it's hard to read this here, but it says negative rotation right there. And you've got your terminal side knowing where your angle ends. So to keep in mind, it's like then the measure of the angle would be found in this little corner right here, or found in this little corner right here. All right. And then another thing to think about, kind of going back to labeling these sides, is if we are going with a positive rotation, just like we did on that last slide, we'd have 0 degrees, 90 degrees, 180 degrees, 270, and 360. Now, if we're going at a negative rotation, we still have 0 degrees right here, but if we're going down this way, this could also be considered a negative 90 degrees, a negative 180, a negative 270, and a negative 360. So I think that negative is a nice clue, because if you see a negative angle of rotation, it lets you know that from that initial side, we're going down first in the clockwise direction. Where when we have positive angles of rotation, you know we're going from that initial side, it's going up in the counterclockwise direction. All right. These are some good notes to things to have written down in your notes. It will help you as you learn this new vocabulary. You want to make sure you know your initial sides and your terminal sides. Have the idea of a positive rotation like this one on the left and a negative rotation like the one on the right. Pause the video if you need to add more to your notes. All right, so some questions you might be asked. It's good to know what a standard position of an angle is. That'll come into play later to help you a little bit. So to draw an angle in standard position, the one ray or one side of your angle will always get to be on that positive x-axis. So you won't, you're already half done without really doing much thinking at all, okay? Now a negative 200 degrees lets us know we're gonna go in that negative rotation direction. So I'm gonna label this as a negative 90, a negative 180, a negative 270, and a negative 360. So I automatically know it's to get to negative 200, we're gonna rotate, my spinner is gonna rotate down. And if it gets here, it's gone negative 180. That's almost far enough. If we go all the way to here to negative 270, that's too far. So I'm going to kind of guess and do a little sketch to say that that negative 200 is going to be right about there. All right, and then what's really nice to do a lot of the time is to kind of remind everyone of the direction of the rotation. So I'm going to put a little arrow there. It started at that purple, went this direction around. So that's that negative 200 degrees. Some people like to write it there. Some people like to write it down there. You kind of have to see what your preference is. All right, this next one, positive 430. This one is kind of interesting because what's happening here is that it goes more than once around, because you draw in that initial side. It's always at the origin, positive x-axis. And now if we rotate our spinner, I wish I had like a smaller thing than this pen. If we rotate our spinner one full rotation around, we've gotten to 360 degrees. And so we still have more to go. If we do 430, if we take off 360 degrees, we still have 70 degrees left. So let's think about where that would be. 0 degrees, 90, 180, 270. All right, we've done a full rotation to get to 360 and we still have 70 left. So we don't want to rotate all the way up to the 90. We'll end, it's pretty close. 70 is pretty close. I'm going to guess it's right about there. And then what I like to do to draw in like my arrow, so we remember that we've gone more than once around. I'm going to draw one full circle and then end it there. And then that has the 70 degrees or the 430 degrees. One new piece of vocabulary is that the idea that 70 degrees and 430 degrees actually ends at that same spot. That's called coterminal. Because they're ending, they end in the same spot. All right, I need to pause this video for a second because my dog needs a little help. We'll come back.